Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new cyber frontier.
Welcome to today's episode of New Cyber Frontier. On today, an exciting episode with a serial entrepreneur, Dan Mapes, founder and president of Versus AI, also founder and president of the director of the Spatial Web Foundation, and a best-selling author. We'll have to talk about that as well. Dan, welcome today. Thanks for joining.
Great to be here, Christopher.
So give us a little bit about your background. How did you get where you're at? I hear all kinds of excitement when you talk. I want to take a step back and just soak it all in. But tell us about your background.
Well, I mean, what a great moment in history we're living through right now. I mean, with artificial intelligence and metaverses and cryptocurrencies, I mean, the technology landscape is really just remarkably exciting with huge opportunities. And so, I'm from the Bay Area and Silicon Valley guy, and I went to school at Berkeley and launched a few companies in Silicon Valley and sold them. And so I've really been in the Valley pretty much all my career, worked in Europe and Asia as well, but really Valley-centric. And it got pretty obvious to me that we're really sitting on top of a constantly evolving bandwidth and chip speed increase. And that opens up, unlocks new opportunities every 15 or 20 years or so, because Moore's law and Metcalfe's law and these things keep emerging, and suddenly now you can do all these things you couldn't do before. And so the two big technologies that were pretty obvious that we're going to combine were virtual reality and then artificial intelligence. You put those two together and wow, learning environments, health environments, all kinds of new kinds of capabilities would emerge. So I kind of had that in the back of my mind, but that required a lot of bandwidth. It required a minimum of widespread 5G, other kinds of high bandwidth networking capabilities. So it wasn't possible to really put this stuff together in, say, the 90s or the early 2000s. You really needed to wait till now. Well, we've got the bandwidth to do it. And so but I did a lot of R&D on it, and I had a R&D company called CyberLab, and so we did a lot of research. We did a lot of work in computer gaming because that's kind of where you could put AI and VR together inside a computer game, but it wouldn't really run on the internet. You usually had to play it on a PlayStation or an Xbox or a jacked up PC or something. So what we really want is AR, VR. AI and now, of course, blockchains and cryptocurrencies all put together on the internet. Well, obviously that won't work on the World Wide Web. World Wide Web's in 2D. It's a web page. So that's why it's called Facebook, and that's why it's called PageRank. It's all about pages. But gaming is all in 3D, and our world's all in 3D, and our cities are in 3D, and our globe is in 3D. So we really needed a 3D web. And then how do we make a web? Oh, well, Tim Berners-Lee, with a few friends, got together and wrote HTTP and HTML, and released it into the wild, and people started building websites all over the world. And now we're up to, I don't know, 3 billion websites or something. And, it's remarkable because there's no friction on these protocols. They run on an open standard, so anybody can read them anywhere in the world and build things in them. And then you build things on top of the protocol like Shopify or WordPress to make it easier to build the websites. So we said, well, why don't we just do the same thing for this 3D web? We'll have a team that puts the protocols together for it, called the Spatial Web Foundation. And you can go to spatialwebfoundation.org and read about that. And then on top of it, we'll build the application layer, which would be like WordPress or Shopify or Wix or tools like that help people that want to build these 3D applications to make smart cities, smart hospitals, new kinds of education, other kinds of things. And so those are the two companies. Versus AI builds a set of kind of like almost we're building like an app store almost, or so that anybody can build these things, but then they're running on a protocol, so then anybody in the world can access them. So it's a worldwide protocol running on the internet. So it's an internet standard in partnership with the IEEE, and that's being released this summer. And probably it'll be more widespread, I would say, probably starting in the new year of 2025. But we're going through we've had the final draft vote, the third draft vote on the standards. So they'll probably become official probably by September, and then start really spreading, through late 24 and into 25 and beyond. So 2025 and beyond could be the explosion of a 3D internet.
Interesting. Well, let's take a break here from our sponsors. We'll be right back. I want to unpack this a little bit more. Be right back.
Blockframe technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dan Mapes, founder and president of Versus AI, Spatial Web Foundation. And wow, that was a lot to take in. Tell us, where do we start? It's like, tell me about the development of the standard. Let's go through that first, because I've heard about this, but it was always such a future far out thing. So tell me about the process of developing the standard, and that, is it, where's it at in testing phases? Does it actually work? Is it still kind of being penciled out with ideas? Where, tell us about that progression.
Yeah, I think the best way to understand things is sometimes understand the history of things. So look at where did the internet begin? Well, the internet began 50 years ago, and right here in Los Angeles at UCLA, and we linked up 4 computers, one at Stanford, one at UCLA, one at Santa Barbara, and one at Utah, and could test, could we make a network with no big central computer coordinating everything? Because that's a single point of failure. If the main system goes down, all of the other pieces go down. So ARPA, DARPA, UCLA got together doing an experiment and launched the original internet back in 1970. And it's grown. And I think it started with 4 computers. I think we had 40 million computers in 1994. We're at 40 billion computers today, all plugged into the internet. We got 150 billion IoT devices plugged into the internet. So it's been a very successful experiment all over the world, with fiber optic cables and satellites and cloud server farms and AWS, and it's a monster multi-trillion-dollar infrastructure that we put together, linking all the computers in the world and all the cell phones and all the laptops and everything. It's really a remarkable thing that happened, and it really all runs on one simple protocol. How did they solve the problem? Oh, you don't let any company own the protocol. It's an open protocol owned by the world. It's a global common standard, and so called TCP/IP. And the way they figured out how to do it is, in the past, the DEC computers wouldn't talk to the IBM computers, and later other computers. They were all siloed. They had their own world they lived in. And so the ARPA team and people working on the internet protocol realized, well, maybe if we do something like electricity, where we describe the standards so that everybody agrees to it, and then we'll give every computer a unique IP address. And then my computer, we call it email. I think I'm sending you email, but it's just my computer sending a text file to your computer. And
Mm-hmm.
that's really what enabled a global communication system. And the great thing about it, it was very resilient. Computers could fail and crash, and the network would still keep working. And you could
Mm-hmm.
fix that computer, replace it. In the old days, before that, if a main computer went down, everything got shut down. So it was a brilliant idea. It worked really beautifully. And from 1970 to the early 90s, the internet grew. And finally, all the major corporations were plugged in and sending files back and forth to each other. And like I said, by 94, there were almost 40 million computers plugged into the internet. It's really remarkable. And so
Mm-hmm.
Tim Berners-Lee came along in the early 90s and went, well, we've got the speeds are picking up. The chips are getting faster. The network's getting faster. We could do more than just send little text files. We could
Mm-hmm.
send fully formatted scientific documents with images and fonts and all kinds of things. And we could do the exact same thing that we did with the internet. We'll give every page a unique ID called a URL. And then we'll give it a protocol. Instead of TCP/IP, we'll call it HTTP, Hypertext Transfer Protocol. And now all the pages can hyperlink between each other. And then we'll do one extra thing that we didn't have to do before, because we want to create formatted pages, not just text files. So we'll create a formatting language, HTML.
Mm-hmm.
And then we all agree on that formatting language. Then one browser can read all the pages in the world.
Okay.
And pretty much launched that almost single-handedly with a few friends. And the thing blew up, and I think we've got 3 billion web pages or websites today.
Mm-hmm.
Billions of web pages. So brilliant ideas from very simple things. These little protocols are very simple. So when we're ready to do the 3D internet, well, then just look to the past. How did they do it? Oh, give every item that you want to connect on the network a unique ID, and then give them a protocol so that they have a way of communicating with each other. Oh, well, there it is. So then instead of HTTP, hypertext transfer protocol, it's about transferring text across the network, then we'll create a hyperspace transaction protocol for monitoring transactions in and between spaces, which is what humans are doing every day.
And then using IPv6, is that what you're saying, with everything having its own ID?
We use DIDs.
Okay.
So they're like that. So DIDs are a W3C standard, well understood. So everything gets a DID. It could go down to a cup, could go up to a building. And so in a spatial environment, see, in the World Wide Web, everything is on one level. So you just go from Amazon to Google to Facebook. You're just moving between websites. But in a spatial environment, you might have a restaurant, which is a space and it has a domain, is restaurant, but it's in a building, which is maybe 30 stories tall with other businesses in it. But the restaurant has to pay the building. So the building itself also has its own.
So virtually you have like the building wrapper, and then the restaurant wrapper, and then the refrigerator wrapper inside the
Oh,
restaurant.
you could go all the way down if you went, and then you could even have a city wrapper, the whole
Okay.
thing. So you could have LosAngeles.com.
Does this have like a vector, so three-dimensional to
Yeah,
it,
it's
or is it
all
just
just like a game. If we look at big games like Fortnite or World of Warcraft or any of these big games, they're big world games, right? Gears of War, all these things, and so they require who's allowed to do what, where, for how long, what level do you have to be to go through this door, what equipment do you have to have? Well, luckily, gaming's provided a lot of the languaging we needed to
interesting?
describe all that. They're called scene graphs, or other ways of describing the rules and programming for computer games. Well, that's exactly what we need. We don't want, let's say, we don't want any cars in the city center on Wednesdays and Fridays between noon and 5. Well, now you can set that. You're at the you're the city council. You set that. Now it's implemented. Well, then the AI just enforces that at the city level. You see what I mean? And so no
Interesting.
cars come in. So now you've in a way kind of gamified the entire planet.
Okay.
And
So
that helps you.
now when that's a very good explanation here. And we're going to take a break here from our sponsors, but I want you to think about this as we come back, because I want to know, how does security get implemented in that? And I know you said security is going to be integrated now within this, and I want you to explain to our listeners, based on this spatial arrangement you just outlined, how do we package and make security in there from the beginning so we don't end up with the same or similar problems we have now with cybersecurity? We'll be right back after a break.
Blockframe technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dan Mapes, the founder, president of Versus AI, the Spatial Web Foundation, and some other things, but exciting, interesting topic, talking about the development of protocols using of all things we've learned from the gaming environment, the three-dimensionalness of different objects, and relate that to the new web, which people then, and objects that we have physically or even virtual instances of them, digital twins, I guess, fit into that realm, are now part of this. So before the break, we talked about security. So now tell us how security integration looks in the world you just kind of presented to us.
Yeah, so what we're doing, of course, now is building a 3D copy of the world. Some people call it a digital twin. It begins with digital twins of individual buildings, but probably by 2035, most major cities have a perfect digital twin of themselves. Then they can update that twin moment by moment with cameras and satellite feeds and things like that. So you've kind of got a living digital version of our planet, right?
Mm-hmm.
So now you can credential things. Who's got the right to enter here? Who can do this or that? So we built self-sovereign identity into the core of the system, which also then enables zero knowledge proofs. So that's a really nice level of personal security. You own your data in the spatial web, so you can't be surveilled with surveillance capitalism kind of thing. So the old models from the World Wide Web kind of go away. And then, of course, you just like our houses versus our banks, the level of security in my house might be an alarm system, whereas a bank, I might literally have armed guards, So then each spatial domain, each space online, depending on the confidentiality of it, can layer in as much extra layering of security as they want, biometrics, other kinds of things. So security is really amazing because let's say if fingerprints are 90% accurate and iris scans are 90% accurate and voice prints are 90% accurate, but if you put two of them together, they become like 97, 90 plus 90 and then 90 again. And so you can add layers of security as you like. And now we're obviously getting the quantum proof security as well. So we don't have to install that level of it, just like you buy your house and you decide how much security you want around it. You're going to be able to apply that. But you've got the fundamentals of the rules of the road of the game built into the system so that you can say you have to provide this level of before you can enter. You have to prove that you're this person, you're a member of this club, you're over 21, you're a subscriber, you're whatever. But now it's much more of you can't spoof the system as well because the system is aware of who you are and what's going on. So you have self-sovereign identity. But right now, you go into a nightclub, you have to show your ID card. Well, they've got a camera could be picking up your address and name and everything on there. But with zero knowledge proofs, you only provide the knowledge that's required for this. Are you over 21? Well, in the future, you'll walk toward a club and you just have a green check mark over your head, over 21, over 21, over 21. Somebody's got a red X over their head. A bouncer might pull them over and go, "Oh, come here for a second." And they come over and, "Oh, I'm from Portugal and I've got my passport here. I'm over 21," but they're not recognized. So there's a lot of interesting levels of security that you will be able to apply to your data, which is the key to the whole thing. Right now, we have nothing. I mean, we're completely wide open,
Interesting. So working a lot with data lineage, we'll say, and cyber physical. We're looking here at entire virtual being, entire virtual everything. A lot of security is about people misclaiming what they are. So, your example of no cars is allowed in the town center between, in these 2 days because they're having a picnic. So, I bring my radio that has 4 wheels, fits 4 people in it, is shaped like a Corvette, but it's my radio. And the thing, and I'm just kind of pointing out with security, if everything's virtual, oftentimes security is borrowing or copying or masquerading as something else. How do you intend or see that particular piece working?
That's a really good question. I mean, there's so many ways of getting at these things. I think if we're looking, we're actually looking at a physical world, a digital version of the physical world, but we're also interacting with the physical world. It's kind of cool.
Mm-hmm.
So you're going to have AI everywhere here in this next decade. We're already seeing an explosion of AI in 1 year since ChatGPT came out. It's only been a year and a quarter now, and it's just already everywhere. But by the time this stuff really spreads around the planet, it's 2035, right? I mean, it's going to take us 5 to 10 years for smart cities to really start popping up, more than just, say, building a cool 3D education site or something. You start running cities and airports and things like that, now security starts to get to be real. And so we really apply everything that we're already using at the airports as an example. Who's allowed to come in? If you don't have a ticket, you're not allowed to enter the boarding areas. There are people standing there guarding for it. Well, in the future, that will be AI. Obviously, a lot will be happening there, and so you'll have to prove that you're a ticketed passenger, and the same thing will happen in other areas. So we kind of see it as being kind of a layered security system, depending on the criticality of what you're trying to provide the security for. But I think with the AI and other kinds of systems that we'll have at that point, you as the provider of the airport services, or you as the provider of the hospital or whatever, you'll be deciding what security you want to apply. We're a framework that allows you to apply that security. That's really, think about it. We don't do this.
So it's all in the data model, so to say, and what's transitioned back and forth. So, we're going to look at similar issues we have today with the cyber physical connection. Am I really what I say I am? Am I not a copy of 100 people in your bar, but I only see one person, but the digital world says there's 100 in here and they're all just copies of some one person or multiple fabricated people? Those type of things, sounds like there's still some questions involved.
Well, you're going to have, the other thing you're going to have is right now AI is monolithic.
Gotcha.
So AI sits, you open AI, it's a giant trillion parameter machine. It's a giant Q&A machine, and you get to ask questions and it answers you, or you get to Dolly, you get to ask it to, give me a piece of art with a panda as an astronaut on the moon, and it'll do all that for you. But where it's going is decentralized AI. So then you have AI everywhere. So they're all talking to each other, right? They're all aware of each other. So you're going to have a harder time spoofing the system.
So what would you say about if my AI was feeding purposely or accidentally wrong information? And you have 100 different AIs, you don't know which one is feeding wrong information, which one's right information. Is that, that's kind of what we're looking at now as AI comes on to the scene. Wait, it's producing sometimes bad decisions or information that doesn't make sense, or what do they call it? Uh, oh, they have a word for it. It's like, oh, it's messing up sometimes.
Right.
How do we be able to
Loose.
prove the right and the wrong? Is it the same as we have now with proving information from people, whether it's right or wrong? I guess it seems like that problem magnifies with AI, and the
Well,
ability to tell what's real and what's not, what's accurate, what's not, becomes more the issue than the speed of making it and the amount of participants and the availability of it.
yeah, what the protocol enables is credentialing. You've already established your credentialing online, and so I can't see into your data vault, but you've already credentialed yourself with whoever it is,
Mhm.
whether you're a member of a club or whether you're a customer of a bank or whatever it is. So you still have your normal credentialing process. We enable that in a data vault way so that
Gotcha.
you have personal security over your credentialing, but the system is credentialed, so it has the ability to require credentials and if this robot is credentialed by the medical board to take blood pressure at the USC Medical Center. So it can't do anything else. It's not allowed to do anything else. It's got that credential, and that's what it's allowed to do. It's not allowed to leave the medical center. It only operates in the medical center.
Uh-huh.
If you want to move it from USC's medical center to Kaiser Hospital, you have to go to the credentialing facility and request a change. And now it's allowed to be entered into the Kaiser system, but it's not
Gotcha.
allowed to give you medicine. It can only take blood
So
pressure.
I'm hearing that there's a credentialing, a trust system in the background that has to exist, that you're kind of making an assumption that that will be there by the time this comes together.
Well, if we look at the World Wide Web, there are two primary protocols. There's
Hmm.
HTTP and then there's HTML. So
Hmm.
HTTP creates the networking protocol to connect everything. HTML is the formatting routine that is the language, hypertext markup language. And so on the spatial web, we have a hyperspace modeling language.
Hmm.
And so credentialing is all built into that, just like in a computer game. If you're playing a game like Game of Thrones, the cities are pretty far apart in the game.
Hmm.
It take you a long time to walk there. But if you're above a level 35, you can get on the back of an eagle and fly there.
Yeah. So the
The
credentialing
system
system,
has to know that. You see what I
the
mean?
the credentialing systems of interest to me. Um, the credentialing system, let's say for a game, right? You have a permission because you will all log in through your account. But now in the real world, you have a credentialing system for a hospital, a credentialing system for a government, a credentialing system for a maintenance worker in an industry, an energy industry, let's say, a credentialing system for a bookkeeper, a credentialing system for accountings. So now we have more credentialing systems, and they all have to coordinate and interact with each other.
Exactly.
The
That's
trust between them and
that's what
it seems
webs
like
do.
the human part of that is is a big kind of question, solving that one first. I bring this up because that's kind of the my lifelong piece of solving that problem has been what I've been working on. But it sounds like those two things come together very successfully.
Well, again, what you do with these technologies is you build a framework so that smart people can continue to evolve on them. So you build
Gotcha.
it large enough and capable enough so that basic credentialing is in place, but then you can take it more advanced. The AIs will help a lot with that. And so there'll be fraud detection AIs that are in the system that are looking for certain patterns of behavior that are fraudulent. And so it's a cat and mouse game, right? I mean, it will always be. But I
Gotcha.
think as we move into this next wave of the internet, which you could argue in some ways was the ultimate goal state of the internet the entire time. It
Hmm.
isn't just a it isn't just a global network of computers that can send messages to each other. It isn't just a global network of pages that creates the largest library in the world. No, it's a global nervous system that helps us manage our planet, helps us
Gotcha.
manage our cities, our supply chains, so it can
Hmm.
see that, oh, those computers just left the factory in China. They're now at the port in Shenzhen. Now they're on the containers on the ship. Oh, it's arriving in Rotterdam on the 23rd of May. And so therefore the whole system is, aware of itself. You see what I mean? So you have
Gotcha.
a new global nervous system emerging, which will, just like our nervous system, while I'm sitting here talking to you, I'm forming a lot of ideas in my brain, and I'm exercising my tongue and my mouth to say those things. But a big chunk of my brain is running my body. It's
Mm-hmm.
digesting my food, beating my heart. I don't have to do that. Well, how's that working? That's like an AI in there. We call it the autonomic nervous system. So what we really want to do is automate a lot of the things in the world that are now manual. And
Mm-hmm.
suddenly we can kind of get control of our carbon footprint and other kinds of things because we have a more accurate global accounting system. So that'll
Yeah.
keep super overheating and other things like that. So this nervous system brings a lot of self-awareness with it. It knows what's going on in its nervous system. If I put my
Mm-hmm.
hand on something hot, even though my hand's way over there, as soon as I feel it, immediately, lift that thing right up, And
Yeah.
so if the internet turns into a global nervous system with kind of intelligence at every node, wow, well, you have a
Yeah.
smart. We've been
That's
talking about
interesting. So give us a
no,
time frame, a timeline for this. Give us your key points and your timeline of when you see this coming in. Kind of, we're wrapping towards the close, but give us a timeline.
No, I think it's every 5 years. I mean, the launches in 2025, or the code's been working for the last 3 years in beta. We've been doing drone management and factories and warehouses and different things like that to test it. But it'll go out in general use probably from January on next year. And so from 25 to 30, it kind of obviously just is what the World Wide Web did. Kind of we spread pretty rapidly. And then you've got super AI coming in by 2030, maybe fully sentient AI. That's a whole new game. And then from 25 to 35 is something with AI sentience coming on board by 2040. Oh my God, you're really getting into, people are starting to get married to robots and stuff. I don't know. I mean, we're moving into science fiction land from
All right.
2035 on,
All right.
But I think the spatial web protocols will allow us to create a kind of a global game space that we can all operate in the 2030s, and that'll be very, very useful. And then let the crazy science as it appears on the edge be part of it all. But now they're all interconnected with everything. The robots are online and everything else. So we get better chances of alignment with robotics and AI and other kinds of things like that. And probably an explosion of abundance, which is really important,
Interesting. So, anything that you need help with, or you'd like to get our audience to participate in or check up on, go ahead and give a shout out now as we close.
Well,
out.
I think I'll go to the website, VERSES, versus like universes or metaverses, VERSES.ai, and keep your eye on it. If you're a developer, you can sign up for our developer program. That'll come on stream in the fall. And let's all build the spatial web together. It'll be exciting. It's the next wave of the internet. First the raw internet, and then the World Wide Web, and now the spatial web.
All right. Well, thanks for joining today, Dan. We definitely appreciate it and love to hear the excitement and the energy in this new effort. So thanks a lot.
Thanks a lot, Christopher.
All right. Bye.
Bye.